Greetings, good friends. Welcome back to today's session. So today we will be dealing with calculus, how to solve calculus problems. And then as you can see here, question 8 says determine f prime of x from first principles if f of x is equal to 3 minus x squared. So now let's try to find the solution for this question. They are seen from first principles. We should remember that f prime of x from first principle, we need to remember the formula. It says limit as h approaches 0 of f of x plus h minus f of x. All this thing is all over h. Now, we are asked to find this particular question. Now, let's try to solve it. We will be having limit as h approaches 0, and then we have our f of x is that. So basically, we will be having 3 minus into bracket x plus h squared minus 3 minus x squared. So now we will continue with this thing to have limit, this is all over h. Limit as h approaches 0. We still have our 3 minus. So let's solve this part. X plus h squared is the same as x plus h, x plus h. And then by using FOIL method, we will be having x squared plus xh plus hx plus h squared. Let's focus on these two. Remember that we have what we call commutative law in mathematics. So a multiplied by b is the same as b multiplied by a. Therefore, we can therefore say a multiplied by b, it is still going to give us a multiplied by b. How do we make that thing, or how can we make this thing be relatable? 2 multiplied by 3, it is still going to be the same as 3 multiplied by 2. Why? 2 multiplied by 3 is 6, and then 3 multiplied by 2 is 6. Therefore, here, we can rewrite that question, or rather that answer, as x squared plus xh plus xh plus h squared. I hope that will make perfect sense after this explanation. Now that we have this part, I'm going to substitute it here. We should remember that it has a minus, so we will be having x squared plus, we have two of them, 2xh plus h squared. So plus 2xh plus h squared. We close the bracket and then we say minus 3 plus x squared. All of this is all over h. We continue by saying limit as our h approaches 0, and then we'll be having 3. I'm going to distribute the negative. Minus x squared minus 2xh minus h squared minus 3 plus x squared. All this thing is divided by h. I hope this makes sense. I'm going to erase there such that I can take this question up there. Now, I'm going to say f prime of x is equal to, now let's check something. I'm going to collect like terms. I'll be having limit as h approaches 0. I'm going to say 3 minus 3. There is a positive 3, there's a negative 3 here. And then I'm going to have minus x squared. And then there's a positive x squared there. I'm going to have x squared. And then I have minus 2xh minus 2xh. Sorry about that. And then I have a minus h squared. Minus h squared. This thing is being divided by h. Now, these two are going to disappear. The 3 and the x squared are going to disappear. I'll end up having limit sh approaches 0, and then I end up having minus 2xh minus h squared all over h. As you can see on top there, I have an h, which is a common factor, so I can take it out. I'll have limit as h approaches 0, right? And then I'm taking out my h, and then I'll be left with 2x minus h all over h. Then the h's will cancel each other. H will cancel this h. Then I'll be left with this limit as h approaches 0 minus 2x minus h. Then we are given that h approaches 0, right? So therefore I'm going to substitute this 0 where there is h, and then the limit is going to disappear. I'll be having minus 2x minus 0. Therefore, my f prime of x is going to be minus 2x. So now, but let's check if the answer is correct. How do you check if your answer is correct? You used first principles to get to this answer, right? So now I'm going to just derive it, differentiate it without using first principles. We are given that the question is y is going to be 3 minus x squared. All right. So by using power rule, here the derivative of a constant is 0 minus. Here we'll be having to drop 2, and then x to the power of 2 minus 1, end up having 0 minus 2x. I'm gonna leave the 0 out and then happen to have 2x to the power of 1, which is basically minus 2x. Exactly the same answer that we got there when we used first principles. So the whole idea is that you need to be able to simplify this, and then you know this is your function, and then you put it there because it is f of x, the one that was given, and then you continue the algebra until you get to your final answer. But what's the kicker? Here's the kicker. Here and here, you do not stop writing your limit as h approaches 0. Why? Because you have not substituted the 0 yet. You stop writing your limit here in this step because you would have already substituted your 0 there. So that's why the limit disappears. I hope this one makes sense. Let's check another question. Cool. Question 8.2.1. It says dx and then something in the bracket. Let me show you something. Dx, it is the same as dy dx, which is the same as y prime. So if a question asks you, maybe the question is given in this way, just know that they want the derivative of something. So now we have dx of minus 5 plus 8 square root of x. Let's go back to the basics. Before I solve this thing, I'm going to rewrite it again. Minus 5 plus, now let's remember, x square root of x is the same as x to the power of 1 over 2. So therefore, I'm going to write 8x to the power of 1 over 2. All right. Then I can differentiate now because I now have what? An exponent who can drop. My answer will be the derivative of a constant is going to give me 0. And then I have a plus here. I have my constant. And then I'm going to multiply it by the exponent. End up having x to the power of 1 over 2, then I minus 1. The 0 is going to disappear. I'll be having 8 multiplied by half is going to give me 4. And then x to the power of negative 1 over 2. Now, let's leave our answer in a positive exponent. I will be having 4 all over x to the power of 1 over 2. Let's remember that x to the power of 1 over 2 is going to give us square root of x. Therefore, I can rewrite this as 4 all over the square root of x. which becomes my answer. However, we can rationalize the denominator to make sure that we do not have a square root in the denominator by doing this. We will be having 4 all over the square root of x multiplied by the square root of x all over the square root of x. Now, on top there we will be having 4 square root of x. In the denominator we will be having x. How and why are we having x in the denominator? Let's come here. Let's remind ourselves of laws of exponents. Remember, we have square root of x multiplied by the square root of x. How do we write this? X to the power of 1 over 2 multiplied by x to the power of 1 over 2. Our bases are the same. What do we do to the exponents? We add them. We'll be having x to the power of 1 over 2 plus 1 over 2. Therefore, half and half is the same as x to the power of 1, which is basically x. Hence, we got to the answer of 4 square root of x all over x. And I hope it makes sense. Let's proceed to our last question of today. Our last question says, y is going to be equal to minus 4 minus 5x to the power of 4 all over 8x to the power of 3. Now I'm going to do it in two ways. 1 and then 2. This, I'm going to use the method that it is allowed in the CAPS curriculum on how to solve this one. So I'm going to say, before I find the dy dx, I will just divide any of these numerators by the denominator and have 4 all over 8x to the power of 3 minus 5x to the power of 4 all over 8x to the power of 3. And then I'm going to write the denominators, or rather I want to have x's on my straight line. I'll end up having 4 over 8. And then if you can check, the x in the denominator is positive, so I'm going to put it to be negative in the numerator now. And then minus 5 all over 8. I have x to the power of 4 minus 3, which will end up giving me 4 over 8 is 1 over 2, x to the power of minus 3 minus 5 all over 8, x to the power of 1. Now I can find dy dx. My dy over dx is going to be 1 all over 2 multiplied by minus 3, x to the power of minus 3 minus 1, minus 5 over 8 multiplied by 1, x to the power of 1 minus 1. Now I end up having minus 3 all over 2, x to the power of minus 4, minus 5 over 8, x to the power of 0. Remember, everything to the power of 0 is 1. Therefore, we can conclude our answer on that part we have. Or rather, here we should first write this as a positive exponent. We have minus 3 all over 2x to the power of 4, minus 5 all over 8. Then this becomes our final answer. So that was method number 1, the one that is allowed in the CAPS curriculum. Let's use the one that maybe is not allowed, which is called the quotient rule. The quotient rule says this. I'm going to write it here. Or rather, it's fine. Or let me just show you the formula of the quotient rule. It says, I'm going to have 4. No, it's fine. I now remember something. I'm going to confuse you. Let me not do the quotient rule because it's not even going to be asked. But hey, nonetheless, this is how you should solve this thing. Why am I stopping myself now is because you are writing tomorrow. And then one of you might end up doing this particular question in the way that is not allowed. And then you'll end up not getting it correct. And I won't feel bad. I will feel bad because you would have got it wrong. You would have used the wrong method and they won't make you positive. Now let me do my kicker question, the one that I know they might not ask, I think, but better prepared. If a question says f of x is equals to the square root of x, and then find f prime of x using first principles. Now let's check. I'm going to use a purple color now. I hope it is clear. So we remember that f prime of x, according to first principle, is going to be limit as h approaches 0 for f of plus minus f of x. All these things all over h. Now let's do our thing. We will be having limit h approaches 0, and then we have this x plus h minus x. All of this is all over h. I wrote something here when I was rationalizing the denominator. When you have this thing, note, when you have this 1 all over the square root of 2, you want to rationalize the denominator. By rationalization of the denominator, you will be multiplying this by the square root of 2 all over the square root of 2. And it's going to give you square root of 2 all over 2. Let's make it interesting. 1 all over the square root of 2 minus 2. You will be having square root of 2 plus 2 all over square root of 2 plus 2. All right. So even here, we will be using this particular method of rationalizing now the numerator now, not the denominator. Let's proceed. So what is it that I'm going to do? I'm going to have my limit as h approaches 0. And I still have my numbers, or rather my values, as x plus h minus the square root of x all over h. Now by rationalization of the numerator, I will be multiplying by, I'm going to use a different color, multiplying by this x plus h. There's a minus, so I'm going to put a plus here, square root of x. In the denominator, I'm multiplying basically by 1. X plus h plus the square root of x. Now, I'm going to multiply out now, having limit as h approaches 0, square root of x plus h minus square root of x, square root of x plus h plus square root of x. I have h into square root of x plus h plus the square root of x. Now let's remember our math foil. If I say this multiplied by that, if you can check, the inside of the square root are the same. So I'm going to say limit as h approaches 0, and I'll end up having x plus h. All right. Now let's check something, because there is no enough space. If I multiply this part with that part, I will be have a square root of x multiplied by square root of x plus h, the positive part. And also if I multiply this and that, I will get the same part but the negative part, so meaning they're going to cancel each other. Now I can skip that part and forward to this last part. Negative and positive is negative. Square root of x multiplied by the square root of x is going to give me x. All right. And then in the denominator here, I'm going to keep it as it is. Square root of x plus h plus the square root of x. So I'm going to take this thing and write it there. So if you can check something, we have negative x and positive x, right? So what is it that I'm going to do? I will be therefore saying, oh, I nearly used the wrong color. F prime of x is going to be limit as h approaches 0. On top, what is it that I have? H. Denominator, I have h into square root of x plus h plus the square root of x. Now, this will cancel that. I'll be left with limit as h approaches 0. On top, I have 1, and then I have square root of x plus h plus the square root of x. All right, now let's check. I can substitute the 0 because h is approaching 0. And then this is going to disappear. I'll end up having 1 all over the square root of x plus 0 plus the square root of x, which is going to give me 1 all over square root of x plus square root of x. So how many square roots of x do I have? 2. So I have 1 all over 2 square root of x. This is my final answer. But I can therefore rationalize the denominator as I showed you before. But now, before I do that, I want to show you how to differentiate it without using first principle, just to confirm if our answer is correct. By differentiating this, I'll be having dy dx of x to the power of 1 over 2. So I'm going to drop the 1 over 2, and then x to the power of 1 over 2 minus 1. I'll be having 1 over 2, x to the power of negative 1 over 2. I write it as a positive exponent. I'll be having 1 all over 2 x to the power of 1 over 2. And then remember, this is the same as square root of x. So I'll be having 1 all over 2 square root of x. And this is exactly what we got when we used first principles. I'm joking. That is mathematics. Nonetheless, this is basically what I wanted us to solve, or rather to look at today, and I hope it made sense and you understood. Check your subscribe on that particular button and then ask questions in the comment section, and also share these videos. They might be helpful for someone, and then also invite everyone to ask. Thank you very much and see you soon. Bye bye.